So the fundamental construct of a GraphQL is that it must have its own type. It has its own type system that is used to define the schema of an API. Now, the syntax of writing a schema is now what we call the schema definition, schema definition language. And if you take a look at this example, if you take a look at this example, you can see we have defined a book. We have a type book and a type author, and we can see that inside the book, we have some fields. We have the title, we have the description, the date it was published, and the rating. So this is just an example of a schema definition language. So queries. Now, when we talk of queries, when you talk of a query from a layman's language is just kind of when someone's asking for something. So obviously, if you're using an API, you have to make some queries to get some data. If you're the client, you have to make some queries to get data from the server. So these are an example of a simple query where in this case, in the first example, we have the book and we are requesting the ID of the book and the title of the book. And the good thing about it that we can also embed, we can also nest these queries to get more details about the author and about the author of that book. So this is a simple example of a query. Now, when we talk of mutation, so when you talk of mutation, I think you know mutation from biology, kind of changing something. So most of the cases, you will have to change some data that is provided, the data that is in the server. Let's say I want to delete something, I want to update something. So mutation is what makes it possible for us to change the data that we have in the server. Now, I've already mentioned that the main three types of mutation. You have you can create, you can update, and you can delete. So I think Alex is going to give us a clear demo of this. And we have said it offers real-time connect. Okay, I mean this is subscription. When you talk of subscription, is when the client subscribes to a given event in the database. So what happens? Let's say you create a mutation that you have a mutation for creating a given record. You create a given book. Then normally, if you don't create a subscription, what will happen? You'll have to make another query to get the latest new records. But in an event where you make use of subscription, then the server automatically will be updating the client. That is the client who subscribed to that event of the new records that have been created. So it kind of becomes a real-time communication. So you don't have to keep on making requests each and every time or each and every second to check if there's new data in the database. So that's what subscription handles for us. Then we have the resolver function. Now, resolver functions defines the actual implementation of an API. And the resolver function always takes 4 arguments. And we have the parent. And the parent, so it's also called the root. So it's like the main entry, where we start writing that resolver function. Now, normally, a query are resolved by the GraphQL execution engine, which invokes the resolver for fields contained in the query. Now, because queries can contain nested fields, there might be multiple levels of resolver function. Now, the parent arguments are always represented in the return value. So you can see an example over here. We have the query that is like the root of that specific query. We have the arguments. You can enter arguments into, you can also write arguments into the resolver function. And we say that potential arguments that were provided by the field, e.g. the name of the user, and this is where now you can even filter the amount of data, like filter like you need this given amount of age less than or greater than this kind of age. Yeah, then we also have the information. Let me just think. We have the information. I mean, not before you go to the information, we have the context, And the context is an object that gets passed through the resolver chain that each resolver can write to and read from. Now, basically, it means it's a means for the resolver to communicate and share information. Then we also have the information, the info, and it's just an AST representation of the query or mutation. So that is just the basic of how GraphQL works, and I think I'm going to hand it over to Alex, who is now going to do for us the actual demo of everything. So, Alex, I think you can take over.
Okay, it isn't really going to be a demo. It's going to be like a live coding session. So be prepared that things might break. We are going to build it from scratch, sort of the project. We're going to use Code Sandbox because we don't want to waste time having to install dependencies locally and setting things up. So we understand that NPM installs take a really long time. So for our project, we're going to have 4 dependencies. One isn't listed here. So ESM, for starters, allows you to use the JavaScript ES6 syntax. For example, the import instead of the require statements, if you understand that, and using const and let. Normal JavaScript does not allow you to do that. Apollo server is the library that will allow us to create our schema and our resolver functions and allow us to just define the whole GraphQL API and how it will look like. And GraphQL, yes, Apollo server will help us define the shape of the data and how to fetch it. GraphQL will use it to define the schema and execute our queries and mutation against it. So yes, I hope you all have access to the link. I have posted it in the chat. I'll be waiting to see you all on the live coding on Code Sandbox in a few moments. Yes, so let's cover one more thing. Oh, and Nodebone, the last dependency that will allow us to refresh the server without having to restart it. So it will handle it for us. There are 4 things that we have in GraphQL. We have something called types, and types, it just defines how your data should look like. We have 4 or 5 different types. We have scalar types, which defines the primitives. For example, you have an integer, you have a string, you have a floating point number. These are the scalars. We have object types, which are a collection of fields which will typically contain scalar types and sometimes other object types. We have the query type, which will define all the top level entry points from which the client, which could be either the mobile application, another API, or another web application, will be able to send data to the server, specifying exactly what they need. And we have mutation, which also defines the write operations to the database, the write, which includes creating, updating, and deleting. And we have the input, which will allow you to pass an object instead in the arguments to queries and mutations instead of having to use scalar types. And don't worry if it overwhelms you, you'll get to see this just in a few minutes. We won't be using any database at the moment because I noticed it might get a little complicated. Therefore, we'll just keep everything in memory, and hopefully you'll be able to understand, and we can organize another session on how to read and write from the database using a library such as Prisma, or we can use Mongoose if that works with NoSQL databases. So yes, so kindly hop on to this live sandbox, and then we can get started with it. Hopefully you'll be able to follow along. I have installed the dependencies, and let me share my screen in a moment. Yes, let me know when you can see my screen. Can you see my screen, and is the code visible? Felix?
Yes, we can see your screen.
Okay, good. Still not seeing anyone in the sandbox, really. The viewers. The link is in the chat. We're going to start from scratch, meaning we're going to get rid of all this code that is here. And yeah. Okay, let's get started building our server. We're going to start with a basic type completely, one that you request for hello, and we'll return to you world. That should be simple. So the first dependency, let's clear out. I should have. We'll see the changes on this other screen. At the moment, it just returns hello world. However, in a few moments, we'll be able to create a GraphQL playground. So let's delete everything. Let's start from the beginning. Again, as I've mentioned, I've taken the liberty to install Apollo Server, ESM, and GraphQL for this demo. So yes, our first dependency is the Apollo Server. So we're going to import Apollo Server. As we've mentioned, this is what will allow us to define how we will fetch and write data. And we'll also import GraphQL from the Apollo server, which is in form of GQL. Yes. As we mentioned, we need to define a query, and a query just defines how you read from the database or something like that. So let's go ahead and create a query, which will use the GQL syntax and some backticks, which is the key just next to 1. And here we'll define, let's say we want to query hello. So we'll say we have type query, and we want to return request for hello, which will return now a string, which is compulsory. As I've mentioned, this string here, it's a scalar type. They are all defined by GraphQL. So other types that we have are, for example, int, we have float. Sorry for that. Don't worry, there's 3 apostrophes, they're comments. We have an int, we have a float. What else do we have? We have an ID, which is special. Anything else that I might be leaving out? That's just for the basics right now. So we have defined our query or our schema using our schema definition language wrapped around GQL. The reason we use GQL is to get this syntax highlighting. It can work without the GQL, however, you won't get the syntax highlighting exactly, which will be a little plain and hard to work with. So yes, so once you've defined a schema, you need to define the resolvers, and the resolvers just specify the data or the actual it's the implementation of the API. So we are going to go ahead and create the resolvers, which will be an object, and we at the moment we know very well we are going to return a query, and in our query we just go against whatever you've defined in your schema right here, which is hello, and hello will be a function. Sorry about that. Oh yeah, hello will be a function, and hello world. And we have the first one, which is the parent of the root argument, which just defines your type at a top level. We have the arguments, which we don't have any arguments. That's in case you're creating or reading data and you need some arguments to define how exactly you're going to return it. And we have the context, which is abbreviated as CTX. CTX just allows you to have access to the whole request. So for example, if you need to check whether a user is authenticated or not, the user's token, perhaps if you're using JWT, for example, to authenticate your users, the context will enable you to check if there is a token ID or a token in the request, and if there is a token, you define the behavior that's going to be there, whether you're going to allow the user to make the request or not. And then the last one, which is info, which we can actually leave out. And the last thing now, let me rename these queries to queries. And the last thing now is to define our server. Just like when you're working with Express.js, we work with a server. A server will be able to serve our application. And for this, we'll have to create a new instance of the Apollo server. So const server is a new Apollo server, which takes in multiple arguments. First one, we'll have to pass it to the type definitions, the type defs. However, we can rename our queries to type defs, which is our schema. We'll pass in our type definitions. Other than that, we'll also pass in our resolvers. And that's it. If you'd like to manipulate the context will be a function or an object, and you'll define its behavior in there. However, at the moment, we do not need it. So, and now it's time to listen to our server. And we'll just say server.listen, which returns a promise. And we can extract the URL from this. Yes, we can open the browser pane. We can extract the .then. And then we'll say console.log. And I'll paste in something from here, which is the URL. The server is running on a specific port. So if we refresh it on this other end, that's not working. I wonder, yes, here's the URL. If you have access to it, you can play around with it. It should be the same. And as you can see, let me zoom in a little bit. You have access to the GraphQL playground, which Apollo server creates for us. And if you usually have no idea where to start from when working with the GraphQL API, a good place to start is the docs. And we can see we have hello here, which returns a string. So let's request for hello. Let's see what it returns. And as we can see, hello, the query returns hello world, which is the data that we actually needed. So are there any questions so far regarding creation of the server? Any questions? Please feel free to stop me if I'm going too fast. We've just created a basic server that listens. We pass it in a query of type hello. However, we are going to go to something complex, and we are going to create our own object types in a few moments. So do we have any questions so far? Okay. If there are none, let us continue. So right now, let's create something more complex from this whole thing. Let's create a simple application that we can create books. We can create books, for example, or a product, but we'll start with books. And from this, we can as well read the books from memory. By memory, I just mean you're going to create an object here called let books for example, is going to be an empty array. This means that we're going to read from memory. So yes. So from this, let's go ahead and create our first type. We know we're going to have a type book, right? Now, this is where we'll see GraphQL starting to shine, sort of, or what the concepts that we've covered. And a type book is now an object type that will contain other object types, as well as other object types and scalar types. So for example, we know that a book has an ID, and since it's unique, we have the scalar type for ID. We know that a book has a title, and it's going to be a string. And this has to be compulsory non-nullable, meaning that if we request for it, it should not return null. It should always return a string. Other than that, sorry about that. That's going to, the GraphQL server will start yelling at us, that's for sure. A book has a description, for example. Description is of a type string, and a book as well has a rating, perhaps, which could be a Boolean, or which I forgot to mention. A Boolean is also another type of object type. Scalar type, I mean. Document our work here. And this is, we're going to document this to be our first object type. So in case you would like to see, for example, the power of adding another sort of object type inside book, or just sort of creating a form of relation, we can go ahead and create something like a type author, which we know an author has a first name, which will be a string. Remember, GraphQL is very case sensitive. There's a typo here. Our last name, which is of type string. And maybe we know an author has written books. And to show the relation, we know an author can write more than one book. So in this type, object type, we are going to start with the brackets, and then we are going to refer to this. The brackets just refer that it's going to be a list that you're going to be expecting, which will be of type book, which should not be nullable and not null. The not null will really help. You don't really want your code base having undefined, which is a little risky, trust me. Given we are JavaScript developers, it's very common for that to happen. But yes, let's leave this for now. And in here, if we were to relate a book to an author, we would say author, which is of type author. So as you can see, this is our first example of an object type, which has another object type and a couple of more scalars. However, let's keep this simple for now, not to complicate anything. Let's say that it's a string. Yes. So let's get rid of the authors first. Let's not make it a little complicated. Any questions, please feel free to stop me anytime. I think I should enable the chat here. Where is the chat? Chat enabled. In case you have any questions, you can always post them here. Yes. So yes. So we are done with the first bit, which is sort of the data modeling. You define this. This will help you make your application sort of more type safe in the event that you want to request for books, and this is the schema for the book, and this is what the books are going to look like. So once you've defined a book, we need to add it to the queries, because how else are we going to know we're going to read from it? So we know that if we request for books, books has to return a list of books. So we could say books and books. Yes. And as we can see, the server should be yelling at us that we have not defined the resolvers for it. Oh, we have not yet defined it in the moment. Should be here. Anyway, let's leave that aside. So the next thing that we're going to do is to define the logic that will allow us to request for books. And at the moment, books is an empty array. We already have hello, which returns the string hello world. And we're going to, now with a schema defined language, whatever you define in the queries or in the resolvers is whatever has to be in the schema definition language here. So right after this, we're going to define books. And books is going to be a function. It has no root, which is to be available in the global state, sort of. It's not going to take in any arguments. And we don't need access to the context, so it's just to make it not to be grayed out. So for this, we are going to return books. I believe that should be it for the resolvers. Yes. So let's go to the playground, refresh our server. Sorry, we have to refresh this. Go to the docs. Okay, it's not reflecting yet. I don't know why, but it happens during live coding sessions. Things are bound to break. Again, if you have any questions, feel free to stop me. Okay, still not reflecting. Okay, I'm going to take a different route and restart the server. This doesn't work. I don't know what will. Pardon?
It's returning an error. So just a minute.
Okay.
Fetching some books.
Okay, I have restarted. I hope it didn't kick you out. Okay, I have no idea why it's not returning the books. Okay. Felix, do you possibly know what could be going on? Why it's not reflecting on the server? Or bad gateway? Okay, restart the server again. This is common. I hope this doesn't kick you out, by the way. But occasionally code sandbox breaks, which is okay. And you get a 502, but everything will be fine. In the meantime, anyone with any questions so far? Dennis, Rose, Musyoka, Sonia. Any questions? Okay.
It's still indicating restarting on my side, restarting the sandbox.
Oh, okay.
Successfully initialized. Successfully initialized, but nothing is still wrong.
Okay, let's just wait for it. Let's give it a moment. Okay. No one has any question, really? No questions. Okay. I don't know whether take it as a good sign. Really. And I hope you didn't fork it. If you forked it, you probably don't have access to whatever we are working on. I don't know why that. So does anyone have any questions? Bad gateway. Okay. Try restarting it. Pardon?
Bad gateway same on my side.
Okay. I think this is bound to happen. Okay. Well, this was unexpected. Sorry. Pardon?
Okay. I don't think it is going to work. What if you have a new project? What sandbox?
A new sandbox.
Yeah.
A new sandbox is creating a new project. Still, we do not want to create a new project. Yes. Let's just restart the sandbox again. So in the event you want to play around with it locally, let me post a link to the GitHub. This one is a little bit more polished. Whatever is on GitHub, it has instructions to get it started. In the meantime, it's in the chat. Yes, the sandbox is starting. This was unexpected. Sorry. Successfully initialized. This is where people usually pray to the demo gods. Things go well, because things are not. We do not know why, but it's okay. Okay. We can modify our schema just a little bit for the book. We can include a published field, which will be a Boolean or Boolean, an author, which is a string. Okay. Did you mean book? Oh yeah. Server started, but I think the problem was in the code. The problem was the developer. Okay. Let me close the window. So I think books should show up, which is an array, a list of books. So other than this, we can include books. And as I said, the power of GraphQL is that you define whatever you want, and that's exactly what you get. Unlike REST returns to you whatever has been stored. So a book has an ID, we have a title, and we need a description. Let's close the docs, and you can see the book returns an empty array. Or the other power of GraphQL is that we are able to request for multiple things at the same time. For example, we requested for hello, and we've also requested for books, and that's exactly what we got. So let's get to the slightly tougher bit, which will be creating a mutation, which will allow us to create books. For this, just like type query here, we will have to define our type mutation, which will allow us, will be like an entry point, exposing whatever a client can be able to execute against the server. So we have a type mutation. And for the type mutation, we have create book. We're going to create one, perhaps one at a time. We don't need the root. However, we do need the arguments, since a user, sorry, that's my bad. We're only defining the logic of how to fetch or how to create a book. I mean, so it will be a function that returns a book that we have created. So for you to create a book, it has to take in certain parameters. For example, we need the title, which will be a string. Yes, other than that, we need the description, which will also be a string. We needed a rating, which will be an integer. We need an author, which will be a string. In case you need me to zoom in, kindly let me know. Other than that, we have author, we have a published, which is a boolean. So the last thing we're going to do, as you can see, that's been formatted really nicely. So we're going to explore the last one more kind of type, which is the input. So we can save ourselves the trouble of doing all this by creating an input. I haven't done that. So we can say input create book. Create book. I'm going to take all these parameters. I should make them not nullable. Let's say it here. I believe that is how they're defined. And then we're going to say we accept create book input. So in here, create book input, instead of having to pass this really long or object sort of. So this is the object that you're going to pass that will allow us to create a book in our database. So as usual, what we usually do, let me minimize this. Once you define something in your schema, you have to create, since the schema defines the behavior, we're going to write the implementation. So down here, we're going to say we want a mutation. We will create multiple mutations, and one of them will be create book. And remember, they have to be the same with whatever is up here. Otherwise, it will throw an error, even if you misspell or add the wrong case. So yes, let's minimize this. Create book, we are not going to take any root. However, we will take arguments, and we don't need access to the context. So we can create a const book. It will be an object, and we need an ID which needs a count. Wait. Books.length. I just need to add the count will just enable us to create an ID. Don't really worry a lot about this. Oh yeah, wait, we made a slight mistake here. We're going to create a book. This doesn't matter. The create book input. This should work. And this book here determines the return type, the return of this function, which will vary. We just need it to return a book. So the ID is going to be book. Nothing fancy here. This should be count plus plus. I think that should be the way it should be. Give me a moment. As we continue, what else do we need for our book? In the title, which we'll get from the arguments. The description, which will be in args.description. We need a published, which will be in args.published. We need a rating, which will be args.rating, and we need an author. tags.author. Don't worry, we'll define all this in our function, and then we need to take books. We need to add these to the books. So this will have push, and return the book that we just created. I hope everyone is not lost. I hope none is lost. Any questions so far regarding what we are doing? Or this will add after. We need to add before it saves. Yes. So the logic here is for this mutation function or the resolver function, we get to know how many books are there to help us create an ID, and we create a book which will have these fields, which we'll get from these arguments. We add the books to the book array that is here and currently empty, and then we return the book as the return type. Hopefully this all goes well. Yes, so now for you to define a mutation, you usually start with a keyword mutation. Query, you do not have to. It's usually a nice convention to give the mutation a name just to distinguish them from the rest. How convention as well to give them an name starting with the uppercase. And for our case, let's go to the docs. Let's refresh this. Okay, it's still not showing up. Still not showing up. What is up? What's going on? Start the server. Isn't NodeMon doing its thing? In case you possibly know what is, if you see me make an error, please let me know. Restart this. Please work. Yes. Progress. So we're going to define this mutation create book. Okay, and we know we're going to call that mutation create book, which accepts a couple of arguments, and we know the return is going to be a book. Let's just return the ID, the title, and a description. And for the arguments in here, which we have create book input. Where is it? Where is it? The schema. Create book input. Please tell me it's here. Hey, we know that it takes in a title. Oh wait, it's a book. A moment. Give me a moment. Hey. Oh yeah. Pick a title. Let's call it The Wizard of Oz. Oh, the Wizard. That's a nice name. Reasons. The error that's here. It's mutation create book input. That's still missing. We have the description. Wizard of Oz. Or Oz. Have a rating of, let's give it somewhere around 8. Published is false. And then the author is, let's just say it's Ryan Reynolds. Yes, so keep our fingers crossed, hoping this works. Let's execute it. Cannot return for a null for book.title. Okay. Okay, our first error. Perfect. Book.title. Yes.
Questions? Well, for the ratings, you've written it as a boolean. Yet you.
The rating is an integer.
Oh, I guess
the rating is an integer.
Oh, cool. Reload.
Okay, so I can see the issue on type book. The rating is of type integer boolean. Oops. Has it refreshed on your end?
No, not yet.
Felix, do you see any changes on your end?
Still bringing the error.
Okay. Book not return another book title. Okay, so there's an issue with book.title, probably in the resolver. Tags.title. Okay. Okay, this is where live debugging happens. Internal server error. So create book returned on null. Let's simplify this just a little bit, make sure everything is working as expected. Let's remove this input. Most of the time I personally don't use the inputs. Let's restart the server because node 1 is misbehaving just a little bit. Sandbox starting, server port 4000 has been closed. Restart the playground. Okay. Okay. Yes, and we have a book. So the problem seemed to be the input. I personally will be honest, I barely use inputs most of the time. Maybe that's why it's giving me an issue. However, we've executed a fast mutation, live coded it. So yes, are there any questions? I believe we've covered most, if not all, except for the input, which we will be able to figure out how to make it work at some point. Yes. So are there any questions regarding what we've covered? I think we've covered all the basics: creating the server, creating our mutation, which is create book, and how to run everything. If you'd like to explore how to perhaps include as database, please do. No one is stopping you. It should be super an exploratory session. I wouldn't say it's easy, that's for sure. It won't be easy. Yes. So are there any questions? Musioka, Rose, Sonia, Felix, any questions?
None on my side.
I hope you've been able to see how everything looks and works for a simple GraphQL server. And yes, on your end, you should be able to execute a mutation. Are you able to do so? Let me send you the link of the playground. I've sent the link to the GraphQL playground. You can play with it. Books will probably return a null. As long as the sandbox is up, it should work. Rose, Sonia, Musioka, we've been able to try it.
Just created one.
Pardon?
I think I just created one.
Oh, okay. which is good enough as long as we do not have errors. Because Dennis, the update, we built a simple server. We are able to create a book, and yes, create RESTful books. Any questions so far? Okay, that should mark the end of the session. Let me stop sharing for a moment here. Thank you all for attending. I hope this session has been informative. If you'd like to see more, kindly let us know, whether it's how to use a database, how to even use GraphQL to request from REST APIs, which is still possible. Let us know and feel free to explore. And if you have any feedback, please let us know as well. Thank you. Are there any last words from you, Felix?
Okay, so practice. That's all. Yeah, everything
I
is
agree.
practice.
Yeah, and read the docs, of course. Read the docs. Yeah. Okay. Thank you, and we'll see you next session.
Okay, thank you.
Thank you.